Okay, in this example, we're back to slope of secant lines again. We got three pairs of coordinates there that we have to create a specific secant slope for, so no h's in this example. And then we're going to use A, B, and C and the results from A, B, and C to take a pretty rough guess as to what we think the tangent slope might be. So no h's, no limits, and definitely no rigor, but what we will get in this video is showing you some of your TI-Nspire geometry features that makes this pretty slick, especially when you're playing around and just trying to conceptualize what's happening and understand what's happening. Okay, so let's do the first one by hand. We can set up our secant slope by hand. Let's say one more time, but something tells me it's not going to be the last time we do this. It'll be a difference in our y's, so maybe put on our subscripts. So now, yes, the difference in the y's will be minus 1 subtract 7 divided by 2, which is our second x, minus 4, our first x, which gives us minus 8 over negative 2, or 4 for our first secant slope. Which, keep in mind, is not a great approximation of our tangent slope, simply because the points are 2 units apart and we'd want to see them get a lot closer like we do in parts B and C. So let's see how we can set that up on our calculator, both using just your calculator main features, your fraction template, and then some fancier geometry features. So make sure as you join me here, don't use your scratch pad. Make sure you open up a document so you will have all the geometry features that you need. Okay, so here we are in our TI-Nspire. Let's open up a document and we'll just do some calculator stuff here first, nothing too difficult. So remind you that you have a fraction template, which would make your rise and run calculations probably easier. So let's do our first secant slope there again, which remember was minus 1, minus 7, and our run was what, 2 minus 4. So there's our first secant slope. Use your up arrows. And you can hit enter and reuse that template and then switch your ordered pair. You're going to leave 4 and 7, of course, intact, because that's where we're going to try to take a guess at our tangent slope at that point of tangency. So our second ordered pair, the y value was 5.84 and the x value was at 3.8. There it is. There's our second secant slope. Again, you can have more confidence in this one because our points are getting closer. They're only 0.2 units apart. And then one last time, our third y value is 6.8804. And our third x value is 3.98. Ordered pairs are getting really close together. And that tells me I can probably put a lot more faith in this approximation more so than the others. And it looks like our tangent slope is most likely 6. So let's go ahead now and we'll switch to our graphing app, or graphing window, and we'll look at some of these geometry features that can make playing around with secant slopes a lot easier. So open that up, and type in our function, which is x squared, in your graph entry window. And remember, make sure that's not in the exponent. If you're not seeing an f1 of x there, you'd have to change your graph entry settings there as well. Why don't I show you that just in case? So if you type menu, graph entry, and you can enter lots of things, but a function is what we're working with right here, a quadratic function. So let's type in x squared minus 2x minus 1. And that is that. There's our quadratic. Now remember, if you're working with the handheld device, it's a little annoying to move those. It's not as easy to work with as the computer, but remember, when you hover over something like a label that you want to move, you hit Control, and then you hit the little hand icon in the middle, which will actually close it down, and then you can move it just like I'm doing here. And if things are going kind of crazy, escape keys, aptly named here, it's a good way to kind of bail on something that's not cooperating with you. If you want to turn your grid on, it's probably not terribly useful, but that's under the menu there. View, under 6, grid. Let's put on our dots. Might help us actually count some rise and run if it comes to that. So there's our function. Nothing really new here. No geometry features yet. Let's use a feature we know well. That's menu, number 5, trace, and select number 1. And this will let you walk around your function. You might want the vertex. We don't want that in this case. let's put on our ordered pairs. So I think I'll just type in 4 on my keypad and hit enter, and it'll go right to that ordered pair. On your function, don't hit anything else. Hit enter one more time, and it'll actually stick a point right at that location, graph that point on your function. And then you can move or type in x equals 2, and that will allow us to work with our first pair of points there and start to maybe try to get a secant line drawn here. So hit escape, and I forgot to hit enter the second time, so I guess maybe that illustrates it unintentionally nicely for you. If you forgot to do that, you're in exactly the same situation that I'm in. So hit enter, wait for that black label to pop up, and then you can hit your escape key. And I'm going to move those. I'm not sure if it's worth the hassle on the handheld, but I'll get them out of the way. And instead of visualizing our secant line here, I mean, you can obviously count over and count up. I guess go over 2 and go up 8. You can see that your slope does seem to be 4. But let's actually graph a line. And again, if you're not in a document, you won't see option 8 there, geometry. And the first part of that menu under points and lines probably makes sense that we want to draw a line. Now you have to be a little more careful with this, but I was playing with this a little bit before making this video, and it's not actually that difficult to do. You just have to highlight that point, highlight your second point, and voila, you have your secant line connecting those 2 points. Again, hit escape so you don't accidentally put more points on your graph paper. And you can still, I mean, count with your dots and figure out that your slope is 8 over 2 or 4, but you can actually do one more thing in your geometry window. If we go back to geometry under 8, there's a measurement option here, and it'll actually let us calculate the slope of any line. So maybe clicking down here is safest, so hover with your finger on your touchpad until you can get your little cursor to highlight that secant line. And the problem is it doesn't really know where you want to put it, and I'll just click anywhere there. So that 4 is the slope of that secant line. Now, and again, I'm going to hit escape because you can see over here, by the way, like this slope is still activated. So if you hit escape, that'll disappear. Now I'm able to do this pretty easily because the computer is, again, a little bit more user-friendly. I get to use arrow keys and keypads and whatnot, which is a little more flexible than your touchpad. So if you're able to grab that, you can drag those points closer together, and you can see your 5.39 is your secant slope. If that's not going so well, don't worry, just double-click, and that's pretty easy to do on your handheld device. Double click again there. It usually highlights it once you double click, and you can go back to your original 0.2 and -1, or you can double click and of course start trying to reproduce some of those secant slopes that we did earlier. And the first one happened at an x value of 3.8, and you can see that's gives the ordered pair 3.8 and 5.84. That was our second secant slope that we calculated by hand. You can see the 5.8 is kind of hovering there. So again, if you're able to move that, great. If not, as long as you can still see it. And then we can move those a little bit closer. Better make sure I do the x value, which would be easier, I think. If we type in 3.98, those points virtually coincide. Virtually, but they don't actually coincide, and our labels are coincident there, sitting on top of each other, so you can drag those around. And if you want to zoom in, you can actually, play with that a little further, but maybe not even bothering to zoom in. If you put another maybe couple of 9s on that x value, then you can, your calculator's going to display 6 because it's running out of due to the rounding and displaying the number of decimals that we're displaying here. It's tricking you into thinking it's exactly 6, but it's actually not. And I regret that happening, so I think I'm going to just change the settings here just to show you that, our display digits are set to float 3. I'm going to try auto and see what happens. See if that shows up. Yeah, there we go. If it didn't, I just would have set the rounding to like 6 decimals or something. Because that was an important distinction to make, that the secant slope is not exactly 6, even though the calculator's saying, hey, that's close enough to 6 for the purposes of displaying it with 3 decimal places there for sure. So again, you can play around with that, and if you want to go back to the original and play around with moving that secant around, you can see real bad approximations for the slope of the curve at 4 and 7, and then really, really good ones as you can move it closer. And if you can't, just again, like I showed you a couple of times, double click on your x value and input whatever x value you want. But check this out. Notice our secant slope, which is missing way down there. Our secant slope is 5.89, and when I move that point past the point of tangency, it's still pretty close to 6. It's approaching 6 differently, so it makes no difference whether our points are getting closer. I guess if our second point is to the left of 4 and 7, or if it's to the right of 4 and 7. If h is a tiny little positive, h is conspicuous by its absence in this example, but remember h is the distance between the x values. So if h is a tiny little positive value, your second point will be just to the right of your point of tangency 4 and 7, and if h is a tiny little negative value, your second point will be to the left of your point of tangency. So play around with that. Lots of helpful features. Again, not to be maybe messing with on a paper 2 test question, but when you're trying to conceptually understand what's happening here as we work through our secant slopes and tangent slopes.